Hi, I'm Syed on Mass Online. Today's topic is infinite series. It is the second part of infinite series. So today we'll try to discuss about the test for convergence for series of positive terms. So we'll try to take the series of positive terms and try to check whether those series of positive terms are convergent or divergent. So for that we'll try to apply two tests. So today we'll try to discuss about the first type of test, which is the Cauchy's root test. So how can we apply this Cauchy's root test and check whether the given series is convergent or divergent? Suppose if I consider a series, a summation of un, right? This is a series that we are considering. It's a series of positive terms. It is a series of positive terms, and suppose if I take limit as n tends to infinity, if I take this term un and raise that to the power of 1 by n, then its value will tend to a finite L value. So this where L is finite, where L is a finite value. So in that case, possibility is that the series will be convergent. The series is convergent if this value of L is less than 1. If L is less than 1, then the series will be convergent. Then the series is said to be divergent if the value of L is greater than 1. The next possibility is that the test will fail. Suppose if the value of L is equals to the other possibility, L is less than 1, L greater than 1, the other possibility is when the value of L is equals to 1. So the test fails. The test will fail if the value of L is equals to 1. So this is nothing but the Cauchy's root test. So we'll try to take few examples. Before the example, some basic results which we'll be using while solving the problems. So the first result, that is limit as n tends to infinity 1 plus 1 by n to the power of n. Its value, we already studied this value, its value will be equals to e. And approximately if you use the calculator and see what's the value of e, you'll be getting 2.71, or approximately you can take the value to be equals to 2.7. The next result that you have is limit as n tends to infinity n power of 1 by n. You even studied this value also. So this value will be equals to 1. Another result you have limit as n tends to infinity 1 plus x by n to the power of n. Its value will be equals to e power of this value of x, e power of x. These are few of the important results that you have to remember. So let us take few examples based on the Cauchy's root test. The first question is, find the nature of the series summation n is equals to 1 to infinity a power of n square into x power of n, and the value of a is less than 1. So we'll try to use the Cauchy's root test. It says, if you try to observe this Cauchy's root test, it is summation of un. So in summation, whatever value is there, that is taken as un. So therefore here if you try to say summation of, so this value will be nothing but your un value. So we'll take that as un. So what is given to us? Given to us the value of un. So the value of un is a power of n square into x power of n. This is the value that is given. But if you want to apply the Cauchy's root test, it is un to the power of 1 by n. So just raise to the power of 1 by n. First we'll try to calculate this. Raise to the power of 1 by n. So if I raise that to the power of 1 by n, so raising to the power of 1 by n on both sides, raising that to the power of 1 by n. So here also it is a power of n square x power of n, that is raised to the power of 1 by n, which will be equals to, so you are raising both to the power of 1 by n. So a power of n square whole power of 1 by n. This is x power of n whole power of 1 by n. So let us try to cancel out that n square value with 1 by n. You can see that 1 n will cancel out from here, and what will be left out? We will be left out only with a power of n. So this value will be equals to a power of, you are having n square to the power of 1 by n. If you multiply, what happens? 1 n will get cancelled. What will be left out? 1 n will be left out. Here this n and n will cancel out. You will be left out only with x. So you got n to the power of 1 by n. Now you have to apply the limit. So it is un power of 1 by n. So if you apply the limit on both the sides, you will get limit as n tends to infinity un to the power of 1 by n is equals to, apply the limit on the right hand side also, limit as n tends to infinity a power of n into x. So when I apply n as infinity over here, the value of a in the question is given as a is less than 1. A is less than 1. So if the value of a is less than 1, in that case, what will happen to this infinity value? Alright. For example, suppose if I take the value, just for example, let us take this a value. Suppose if I take this to be equals to 1 by 3. If I raise to the power of n, so 1 by 3 power of n. And suppose if the value of n is tending to infinity over here, n is tending to infinity. So a power of infinity, it is 1 by 3 power of infinity. So it is 1 by, anything to the power of infinity will be infinity itself. 1 by infinity will be what? 0. So this value a power of n will tend to 0 when the value of a is less than 1. So because the value of a is less than 1, this value will be equals to 0. So 0 into x value. So 0 into anything will be equals to 0 itself. Alright. So if it is 0, is this 0 less than 1? So this will be acting as your L value according to the definition. So limit as n tends to infinity un to the power of 1 by n, if its value is equals to L, and the value of L, if it is less than 1, then what type of series it is? The series is convergent. Therefore, we can say that by Cauchy's root test, we have seen that summation of un's, but un value is a power of n square, x power of n in the question. So is convergent. So we have shown that the given series is convergent. So next question is, discuss the convergence of summation n is equals to 1 to infinity 1 plus 1 by n to the power of n square. He has mentioned discuss the convergence. So the given series may be convergence or may be divergence. We have to just check whether it is convergent or not. So given the value of un, so un value is nothing but 1 plus 1 by n to the power of n square. So once you have got the value of un, what has to be done? According to the Cauchy's root test, you have to raise that to the power of 1 by n. So raise this to the power of 1 by n. N square is already there, and raise that to the power of 1 by n. So now what happens is, so n square is there, so it is n square into 1 by n. So 1 n will get cancelled. What will be left out? Only 1 n will be left out. 1 plus 1 by n to the power of n. Now you have to apply the limit on both sides. Limit as n tends to infinity un to the power of 1 by n is equals to, apply the limit on the right hand side, limit as n tends to infinity 1 plus 1 by n to the power of n. If you try to observe this, I have already shown you one result for this. If you can see the note here, note limit as n tends to infinity 1 plus 1 by n whole power of n. What is its value? Its value is e. So directly you can take the formula. So its value is nothing but e over here. And what is E value? Approximately the value of E is 2.7. So is this value greater than 1? So because it is greater than 1, what can you say about the series? The series is divergent. Whenever the value of L is greater than 1, we say the series is divergence. Therefore, we can say that by the Cauchy's root test, summation of un is what? Summation of un is divergent because the value is greater than 1. Test for convergence, summation n is equals to 1 to infinity n plus 1 by n whole power of n square into 1 by 3 power of n. So given the value of un, which is n plus 1 by n to the power of n square into 1 by 3 power of n. You have to raise to the power of 1 by n on both sides. Raise to the power of 1 by n. So we have raised to the power of 1 by n on both sides. So now apply this 1 by n over here. It is n square into 1 by n form. So n and n will get cancelled. What will be left out here? N will be left out. So n plus 1 by n, it is whole power of how much? Whole power of n. Here n is there and 1 by n. So this n and n will get cancelled. We will get 1 by 3. Or further, you can just divide it. So it is n by n plus 1 by n to the power of n into 1 by 3. This n and n will get cancelled. You will get 1 plus 1 by n to the power of n into what you have? Into 1 by 3. So I've just simplified this. You can apply the limit on both sides. So limit as n tends to infinity, un to the power of 1 by n will be equals to limit as n tends to infinity, 1 plus 1 by n to the power of n into 1 by 3 is equals to. So we know this formula, that is limit as n tends to infinity, 1 plus 1 by n to the power of n. Its value is nothing but e. So if I take this value to be equals to e into the constant 1 by 3 as it is. But we know the value of e is 2.71 or approximately you can write it as 2.7 divided by 3. You just divide and see this value will be less than 1. Because this value is less than 1, we can say that the series is convergent. Therefore, by Cauchy's root test, the series is convergent. The series is convergent. Test for convergence, summation n is equals to 1 to infinity 1 plus 1 by root n to the power of minus n power of 3 by 2. So what is given to us? Un value is known, 1 plus 1 by root of n to the power of minus n power of 3 by 2. Now raise to the power of 1 by n on both sides. This has been raised to the power of 1 by n, which will be equals to, now here just try to check it is n power of 3 by 2, that is multiplied by 1 by n. So this is to the power of n power of 1 it implies. So n power of 3 by 2 into, if I take this value, numerator becomes n power of minus of 1. So when the bases are the same, powers can be added. So 3 by 2 minus of 1. So n power of 3 by 2 minus of 1 will be 1 by 2. So n power of 1 by 2. That will be the value. So if I rewrite this becomes 1 by root of n to the power of, negative sign will be as it is. So n power of 3 by 2 into 1 by n, have calculated that value to be n power of 1 by 2. Or you can write 1 plus 1 by root of n to the power of minus, this n power of half represents root. So root of n. That is how you can write. Or if you want to eliminate that negative sign, you can rewrite this value to be equals to 1 by 1 plus 1 by root of n to the power of, the negative power will become positive power. Now you can apply the limit on both sides. The limit as n tends to infinity, un to the power of 1 by n is equals to, it is limit as n tends to infinity 1 by 1 plus 1 by root of n to the power of root n. This will be equals to, it is 1 by, so if you apply the limit, this is similar to limit as n tends to infinity 1 plus 1 by n whole power of n, whose value is e. So if you try to use that result, its value will be equals to e. So 1 by e. So e value is 2.7. So 1 by 2.7 will definitely be less than 1. So this value is less than 1. In that case, what can you say about the series? The series is convergent. Therefore, by Cauchy's root test, summation of un is convergent. Discuss the convergence of summation n is equals to 1 to infinity n plus 1 whole power of n into x power of n divided by n power of n plus 1. So what is given to us? The value of un is known, n plus 1 to the power of n x power of n divided by n power of n plus 1. So we'll try to raise to the power of 1 by n on both the sides. So n plus 1 whole power of n x power of n divided by n power of n plus 1. Raise that to the power of 1 by n, which will be equals to. Now if I raise this to the power of 1 by n, so this n and n will get cancelled, it will just be getting n plus 1. Here this n and n will get cancelled, it will just be getting x. Denominator also you have to raise to the power of 1 by n. So it is n power of n plus 1 into 1 by n. So I'll just show it to you. N power of n plus 1, that is raised to the power of what? Raised to the power of 1 by n. So this is nothing but, you have to just multiply. So n power of n plus 1 into 1, so it is n plus 1 by n. N plus 1 divided by n. So n plus 1 by n. Or you can write n power of, just divide n by n plus again 1 by n. So this will be n power of, this n and n will get cancelled, you'll get 1 plus 1 by n. So n power of 1 will be n, again n power of 1 by n. Just using loss of indices, you can separate it. N power of 1 plus 1 by n can be written as n power of 1 is n into n power of 1 by n. So I can write this value to be n into n power of 1 by n. Now I have simplified this one, or if you want to further simplify this expression, in that case you can take n common from here. Alright, if I take n common from here, what will be left out? 1 will be left out. Because I have taken n common, what will be left out here? 1 by n. Just taking n common from here, I get 1 plus 1 by n. This x value will be as it is, whole divided by n into n power of 1 by n. So what happens is n and n will get cancelled. We will be getting 1 plus 1 by n times of x divided by n power of 1 by n. So this is nothing but un to the power of 1 by n. Now apply the limit on both sides. There is a limit as n tends to infinity, un to the power of 1 by n is equals to, it is limit as n tends to infinity 1 plus 1 by n times of x divided by n power of 1 by n. So I need to apply the limit as n tends to infinity. If I apply the limit for the numerator value as well as for the denominator value, so this becomes limit as n tends to infinity 1 plus 1 by n. Numerator I am applying, whole divided by, for denominator also you can apply the limit as n tends to infinity n power of 1 by n, and this value of x will be as it is. Already shown you initially itself what will be the formulas for limit n power of 1 by n. So if you try to observe here, result number 2 I have shown you already. Limit as n tends to infinity, n power of 1 by n, its value will be what? Its value will be 1. So this value is already known to us. Its value will be 1. And in the numerator, you have 1 plus 1 by n value is what? N value is infinity. Whole divided by. This value will be 1. And this x will be as it is. So 1 by infinity will be 0. So 1 by 0 divided by 1 is 1 itself, times of x. So x into 1 will be x itself. Now we don't know what is the value of x, whether x is greater than 1 or x is less than 1. Based on the values of x, the series will either be convergent or the series will be divergent. So two cases will arise over here. Let us try to see, or even the third case will try to see. So equals to 1 you have. So what I have done, therefore by Cauchy's root test, summation of un is, so whether it is convergent or divergent, two possibilities are there. It can be convergent as well as divergent. So when it will be convergent, it depends upon the value of x. Suppose if the value of x is less than 1, if x is less than 1, the series will be convergent. And divergent if the value of x should be what? It should be greater than 1. So if the value of x is greater than 1, the series will be divergent. And there is one more case. Suppose if the value of x equals to 1, in that case what happens? You have seen, if L is 1, then the test will fail. Therefore the test fails. The test fails when the value of x is equals to 1. So when x is equals to 1, the test will fail. So all the possibilities are there in this example, depending upon the value of x. This were a few examples based on the Cauchy's root test. That's all I have for today. Thank you.